Meron Gribetz, and I'm the CEO of Meta, an augmented reality company. We build glasses that allow you to see holograms and touch them with your hands, as a gross simplification. What do you think of when I say augmented reality? What's popping into your head lately? Pokemon Go. Excellent. I'm going to disappoint you. I think that's exactly not what augmented reality is about. Unlike virtual reality, which is a media viewing device, essentially, an extension of your television or your game console, augmented reality is very much a general computing platform, in my opinion. It extends your phone, it extends your laptop, and so forth. And with general computing platforms, there's a different pattern that emerges. It tends to get catalyzed by a killer application or a set of killer applications that start in one industry, and they permeate horizontally across all industries, and they drive the adoption of this new form factor. And that's exactly what we're seeing happening in augmented reality today. I'm here to talk with you about the killer apps of AR. But before we do, I'd like to give you a few examples of killer apps from the past. Rewind to 1979. The Apple II is out. It sells about 20,000 units. It's essentially a developer kit until a visual calculator, VisiCalc, comes out. This is a tool for accountants. This is a tool that allows you to crunch numbers, essentially, in any company, and to save money or to make money. And it quickly spreads like wildfire across all industry, and it really drives the adoption of this brand new form factor, the Apple II device. Another example of a killer application was desktop publishing. So 1984, things aren't going so great with the sales of the Macintosh until such a application comes out, the desktop publishing tool. So it starts again from a vertical industry, publishing, and it turns out every company in the world needs to document their assumptions, and suddenly all companies are using this across industry. And we have our second killer application, and the Mac sales soar. This is another example. But it's not isolated to that. Turns out that early internet, early mobile, all general form factors start with the same exact pattern. And I believe augmented reality is no different. I'd like to talk to you today about the killer applications of AR. I think AR is going to birth more killer apps than any other form factor that preceded it, for a very simple reason. Our brains are essentially 3D GPUs. We've evolved to process information in 3D. This is the first form factor that works like that allows you to use space itself as an area where you could work with physical tools. Now, here's something to notice about killer apps that we didn't discuss yet that is way more interesting than the business use case, in my opinion. What killer apps like VisiCalc and desktop publishing tend to do is change the interface paradigm for that industry. Before VisiCalc and desktop publishing, it was command line interfaces, which are highly metaphoric, they're abstract, they're symbolic, and they're difficult for humans to interact with. And then came along VisiCalc with its rows and its columns that reminded accountants of exactly how they're used to doing work. Similarly, desktop publishing reminds us of that empty sheet of paper that you might see above a typewriter. So it changes the interface paradigm, and it makes it a lot more familiar. It makes it a lot more easy to use. That's really the most important thing about killer apps. And AR will allow us to create tools that have a zero learning curve. Because even in those older tools, there was still a learning curve. There were still the menus and buttons and icons and complexity. But with AR, we can birth tools that look exactly as they would in the real world. They're exactly as they were in the real world. And that's why we're going to see the most killer apps coming out of it. But it's easy to screw up augmented reality. It's very, very easy to take an application from iOS and throw it into AR, or an application from Windows, like some of our competitors are doing, and just throw it into augmented reality space. Because AR is a superset of computers like your laptop or your phone. You can just It has infinite screen real estate, so you can place as many of these applications inside it as you want. And you don't have to modify those applications. But that, in my opinion, is a mistake. That's like taking Windows and putting on a mobile device. And that's why the Windows Phone never picked up. I think we really need to take a moment and design these applications in an intuitive and in a new way and birth these killer applications. So here's how we're going to do it. How do we create zero learning curve tools for augmented reality? Well, we have to come back to the way that our brains like to process information and interact with information. And my company, Meta, is building what's called the Neuro Interface Design Guidelines. We are open sourcing a document. We're doing a lot of neuroscience research and applying that to intuitive interface design. Now, it sounds kind of cool, but okay, neuroscience and interface design. But this is really the first attempt to look at the science of intuitive interface design and create these zero learning curve computing experiences. I believe AR is going to make computers 100 times easier to use than your phone. And that's a strong statement, but I hope we can achieve it. Let me show you 3 of these design guidelines and how we apply them and birth killer apps out of them. The first design guideline is called Think Spatial. Our visual systems have evolved in a highly spatial processing manner, meaning we've evolved running in the jungle from this 3D thing over here, or from, or in our caves, placing this tool on this side of the cave and this item on this side of the cave. So our visual systems haven't evolved with the flatness of the Windows GUI or the flatness of abstraction. In the new world, we're going to place our content on one side, we're going to place our tools on another side of us, and we're going to unlock the interface paradigm. So we're really changing the interface paradigm from the Windows graphical user interface, born in Xerox PARC over 40 years ago, to what we call the spatial graphical user interface with our first principle, Think Spatially. So don't just clutter those apps into a small screen size real estate. Let it loose. Second interface guideline we call Minimize Abstraction, or Design Tools with Volume. Let's look at an example over here. So you have this eraser, which we're all used to from whiteboards. And there are 2 nooks on each side of the eraser telling your hand exactly how to reach out and touch it. Your visual system is understanding that I'm supposed to grab it in a very, very specific way with no manual. And that's what's so exciting about this. Your motor system gets to plan exactly how it's going to reach out and touch it before you even touched it for the first time. This is the first tool ever created by humans, the Mode 1 rock. Okay, it's a very, very cool thing, and our ancestors had no learning curve with it. It was our primary tool for hunting and gathering for 1 million years. So that's our second interface principle. Our third interface principle is what we call hands-on collaboration. When a professor is lecturing to you via just audio, it's a little harder to have that information stick, right? Whereas if you're in class, if you're sitting in this first row, if you're looking at the professor moving their arms and dissecting a frog in front of you, or explaining a really difficult physical concept on a whiteboard, it's so much easier to understand it, and here's why. You have this beautiful neural mechanism called mirror neurons. Mirror neurons are what are currently making the very front row here, when I'm holding my hand as such, the very same neurons that would have fired if you did the same thing are now firing. That's the neural underpinning of empathy, and it's a very powerful mechanism that helps you understand complex things much better. So our killer application, our first killer application for augmented reality, is going to leverage the mirror neuron principle. It's a 3D model viewer, and it's going to disrupt every industry. Let's look at an example here. So I'm shopping for a Tesla online in the near future, and I could just reach out and touch it in this collaborative manner with another person. That's the future of computing. And of course, this is going to disrupt education, because a professor is going to be able to do the same thing on stage. It's going to disrupt the way that we shop, because we could pass each other a handbag or a dress and just really understand it through this third principle. So that's a killer application, the first one of augmented reality. Great. So That's our third principle, and what did we do here today? We learned about the neuro-interface design guidelines, which are going to create a zero learning curve computing experience, simplifying computing dramatically and empowering us to move away from the Windows graphical user interface into a brand new spatial graphical user interface. And out of this transition and simplification, killer apps are going to be born, and they're going to disrupt every aspect of our life. We learned that it's super duper easy to screw this process up by just copy-pasting applications from the old world, but that's exactly what we should not do, because we'd be giving up the most exciting part about these 40-year computing shifts, the opportunity to rethink the interface paradigm from scratch, the opportunity to look at the power of the form factor and invent specifically for that power. And that's what I hope we can do. But why is this so important? We're exponential thinkers here. We're thinking about the far future. I believe this is important because unlike traditional computing devices like a phone or a laptop, which when you're done working with them, you could place them in the other room, augmented reality will soon look a lot like a contact lens on your retina or a strip of glass on your eyes that you wear all day long. And in fact, Meta is working on one of these, as we announced at TED earlier this year. The near future is going to look like that, and we're going to be living inside of these interfaces. More than that, our kids and our kids' kids are going to be living inside these interfaces. So I think we have this moral obligation to really obsess about the perfectionism of user experience in this transition, and to take a moment now and not just take the last 40 years of computing and shove it in the glass and rethink it and design it based on our own evolution so that we have a comfortable stay for the next 40 years of computing. Thank you very much.